So in this problem, what I want to find is the overall height and the total area. How would I go about doing that? Any ideas? Well, we need some right angles. Where can we find some right angles? There you go, tangent to a radius. So there's a right angle. There's a right angle. And we know that those lengths, being radii, are 70 millimeters. Now what? Like this? Oh, outside? Gotcha. Out here? That might work. What do we know about that triangle? It's a right angle, yeah, because there's a vertical and a horizontal. A 4-to-1 slope. What does that 4-to-1 slope tell us? Okay. What it tells us is if we look at it, I can treat that as being 4 units and that being 1 unit. Yes, 4 times as tall as it is wide. So then, let's find an angle here. How about this one? So according to that angle, the 4 is which side of this triangle? Opposite. And the 1 is adjacent. Of course, that is the tangent function that is opposite and adjacent. So we're going to do an inverse tangent of the opposite is 4 and the adjacent is 1. So inverse tangent of 4 gives us 75.96 degrees is that angle. Which means this angle here, 104.04, perfect. Well, now what? That's 104.04. This is 104.04. That's 90 and 90. Can we find that angle? Yeah, how many sides does that have? 5 sides. 5, remember it's n minus 2 times 180 is your angle sum. So 5 minus 2 is 3 times 180 is 540 degrees. So that figure has to have 540 total degrees in it. So 540 minus 90 and 90 is 180, minus 104.04 and 104.04. Is that 151.92 degrees, I believe? That angle is 151.92. Now, I'm going to cut this across there. Cutting that across there gives me this triangle. 151.92 degrees, 70 millimeters and 70 millimeters. I know these two angles have to be the same because this is an isosceles triangle. So that makes each of those, what is that, 28.08? So that makes each of those 14.04. Because that has to add up to 180 again. Any questions on where I got the 14.04? Just 180 minus the 151.92 and then divided by 2 to split it between the two angles. So I can find this side over here, because it's 70 over the sine of 14.04 degrees equals, if I call this little a down here, that'll be little a over the sine of 151.92 degrees. And we'll cross multiply and divide. 70 times sine of 151.92 divided by the sine of 14.04. 135.82. That's not degrees, that'll be millimeters there. Now that I know that total length, if I cut this here and here, I have this red triangle that I'm going to draw. I know that this angle here is the 75.96. I'm going to try to find that height there, that's dimension there, the vertical. I know this horizontal dimension, or at least I can calculate it rather quickly. How do I know that? Well, if I look up here, this whole thing was the 135.82. I take 72 out of the middle of it. This is 72 in the middle of it. So I've got 135.82. If I subtract 70 out of there, or 72 out of it, that leaves me at 63.82, which gets split half and half. I divide that by 2. So 31.91 on each side. This is 31.91 here. So I can now find B because B is the opposite side according to my angle. The 31 is the adjacent. That is tangent. So I know the angle is the 75.96 equals opposite side is B, adjacent is 31.91. I am looking for a missing side, so I make it a proportion. I cross multiply and divide. So 31.91 times the tangent of 75.96 divided by 1, 127.60 is B. So that gives me up here, from here to here, 127.60. millimeters. Now, from the center of the circle up, I know that's just 70 millimeters. That's just the radius of the circle. So what I need now is this height, which would be the height of that little triangle there, which is just the height of this triangle right here. That height, I'm going to show you a shortcut, then I'm going to prove to you that's right. I'm going to take my 135.82. If I divide it by 2, that gives me this distance here, right? 67.91. If I divide that by 4, it's 16.98. That's 16.98 millimeters. Why did dividing that by 4 work? Well, because it's perpendicular to that 4-to-1 ratio, which makes it a 1-to-4 ratio. For every 4 units of horizontal, there's only 1 of vertical. Now let's prove that that's correct. So this was, so the 67.91 right here on 14.04 degrees. Tangent of 14.04 equals that height times over 67.91 would be my adjacent side. And I cross multiply and divide. So tangent 14.04 times 67.91. We don't have to do the divided by 1. So 16.98, which is what I had. So that height is 16.98. So I add those 3 dimensions up. Which is 214.58 millimeters. Oops, that's not the total area. That's X. Total area comes in another step. First, I'll have this triangle here. Its area is going to be the 127.60 times 31.90 divided by 2, correct? Give us that area of 2035.86. There are 2 of those triangles. There's one on the other side that's the mirror image, so I'm going to multiply by 2, giving us 4071.72. Millimeters squared. So that's for those 2 triangles. We have this triangle here that's 16.98 high by 135.82. Divided by 2. There's only one of those, so it's the 1153.11. We have this rectangle here. It's 72 by 127.60. $91.87.2. And then finally, we have the circle. Our circle is pi times radius squared, but then we don't have a full circle. What we're finding is the area up here. This was, can't read it now. 151.92. So 360 minus that is 208.08. So pi times 70 squared, 3.14 times 70 squared times 208.08 divided by 360. 8893.11 meters squared. And now we get to add those all up. So plus 9187.20 plus 1153.11 plus 4071.72. We get 106,005.14. 106,005.14 millimeters squared. Now, how many meters squared would that be? .106, because it's squared. Every spot on the chart is going to be 2 decimal places. So you got meters, decimeters, centimeters, millimeters. It's 3 spots on the chart, so it's 6 decimal places. So it's less than 1/10 of a meter squared. That's kind of why I brought it up. I figured it'd be about time for it to have faded. Great stuff. There's your homework for today. Find the x dimension and the total area.